Hey everyone, today we're going to look at a great circle sailing problem. I've had a few people email me looking for guidance on these. I'm happy to sit down and provide whatever clarity I can, whether it be US Coast Guard, practice problems, or concepts you're learning in class, or just anything anyone's having trouble with, if what I'm doing is helping people. So like, comment, subscribe if anything you've watched in any of these videos has helped you out. So step one is to always write our givens. I always like to take the pertinent information from the question and write it down in a way that I best view it. So just our lat 1, lat 2, longitude 1, longitude 2. This is step number 1. Step 2 is to convert your minutes of your latitude and longitudes to a decimal form. This one's going to be a little longer because I'm going to show you guys what this looks like in the calculator, because in great circle problems, the most mistakes happen when you're punching the numbers into your calculator. So what you do is you take the minutes. We'll start with latitude 1, 51 minutes, divide by 60, and then you add the whole number. So 51 minutes divided by 60 gives you a decimal of 0.85 plus the whole number, 27. So our latitude 1 in decimal form is going to be 27.85 degrees, and you can see that I have that written down here. We'll do one more. We'll do longitude 1, 41 divided by 60 gives you a decimal plus the whole number, 71.683. I have that written down here. So that's step 2, is to convert your minutes to a decimal. Step 3 is to calculate your difference of longitude. So I would say that this is probably the point in the problem that most people mess up on, is calculating your difference in longitude. The second would be plugging all these numbers into your calculator. So what I do is I kind of draw what I visualize to be a Mercator projection, just a long rectangle with our longitudes labeled. So I start with 80 in the middle and I go out to the sides with 100 on each end. I then label my east-west. So my west would be in the center, 0 to 180, and then my east on the ends, 180 to 100, and then 100 to 0. This way, when I draw my line, I can see the direction of travel, east or west, and then the distance that I'm covering. You can see in this problem that our longitude is starting at 71 west, so I put a little dash with a 1, and ending at 006 west, so I put a dash at mark 2. Wouldn't make much sense for us to go around the westerly direction all the way around to step 2, so kind of have to use a little bit of common sense here, where we are going in an easterly direction at a difference in longitude of 65.45 degrees. So this one's simple. You just add, you subtract from longitude 1 to your longitude 2, 71.68 minus 6.23 degrees gives you a difference in longitude of 65.45. We're going in an easterly direction, so I label that east. That is step 3. Step 4 is to plug into the formula and find our distance. Our distance is going to be in degrees. Our formula is cosine d equals, and this is grouped together, cosine lat 1 times cosine lat 2 times cosine difference in longitude plus or minus your sine of lat 1 times your sine of lat 2. So here we go. We don't have distance yet, so we're just going to start on the right side of the equal sign. Cosine of your lat 1, so we're going to type this in exactly how we see it here, this first section. We have our first parentheses times cosine lat 1. We're typing in the decimal form, 27.85. And the reason we put in the decimal form is because I want to avoid extra inputs into my calculator. I don't want to have to type in 27 degrees, 51 minutes, so on and so forth through every entering argument. I want to have as few calculator inputs as I can. So 27.85 just has a whole number times cosine of lat 2, cosine 49.75 times your cosine of d low. Cosine difference of longitude 65.45. 65.45. All that, and then we want the second parentheses on the end, gives us 0.237. Write that here. Then we will do our second grouping. That first parentheses times sine of lat 1, 27.85, close parentheses, times sine of lat 2, sine of 49.75, and then we want that close parentheses on the end. Gives us a decimal of 0.356. So 0.237 plus 0.357. How do we know whether to add or subtract which symbol we're choosing, the addition or the subtraction symbol? If we're crossing the equator, we subtract. The way you do this is by looking at your lat 1 and your lat 2. Both of these are in the northern hemisphere, meaning that we're not crossing the equator. So we're going to use a plus sign here. 0.237 plus 0.3 0.357, gives you a decimal of 0.594. Second cosine, you get that cosine -1. Second answer, we get the answer that we just found in our previous equation. Close that parentheses, and you get a distance of 53.558 degrees, 53.56 degrees. That is how you find your distance in degrees. And now step 5 is we want to convert it to nautical miles. The way you do that is you times it by 60. 53.56 degrees times 60 is 3,213.6 nautical miles, 3,213. Now already we can see that we're leaning towards answer A. Why? Because this answer is closest to answer A, and none of these other distance answer choices are close. So we're already leaning towards answer choice A, but we want to finish this problem out to confirm that we are on the right track with answer choice A. So step 6 is to plug into the initial course formula and find what that initial course is. This one I like to break down even further, and you'll notice, if you can see it, at the front of this problem there's a plus or minus. Same concept as what we just looked at in the distance formula, which is if we're crossing the equator, we're using a minus sign. In this instance, we're not crossing the equator, we're staying in northern latitude, so we're just going to leave that positive. So here we go. I like to do, in this problem, each one individually. Sine of lat 2, 49.75, and then I write it below, 0.763. So I'm not trying to overcomplicate the math. What a lot of people do, and this is where I see a lot of the mistakes, is they try to type this whole line in at one time, and that just puts too much into one calculator. Enter. It's easier just to break it down, provides clarity, and you can double check your work that way. If you do think you found a mistake, you can trace back into each separate section of each formula to trace down where you made a mistake. The second grouping is minus cosine D, cosine 53.56 times sine 27.85 for a decimal of 0.277. Same thing on the bottom. So you can see I've written that here. Same thing on the bottom. Sine of our distance, 53.56, times our cosine of lat 1, 27.85. Close the parentheses, 0.711. Now it's a simple addition subtraction problem. 0.763 minus 0.277 gives you 0.486 divided by 0.711 gives you a decimal of 0.683. Now we're moving up to this right-hand side. Second cosine, second answer, close the parentheses, 46.87. That's our initial course. 46.87. The next step is to apply our direction for true course. What I like to do is I like to take the the direction of our latitude 1. Go back to the top. Our latitude 1 is north. So I like to make a note of that there. And the direction of our distance of longitude. We're moving east, as you can see in our initial projection. So I like to note that here. We're in the northeast for 46.9. So 46.9, and then we want to take a measurement of how far this angle is from north. This one's pretty easy because we're in the first quadrant. Our distance is only going to be 46.9, which means our true course is 46.9. So now let's look at our answer choices. 3,214 nautical miles. This rounds to that answer. 46.9 for our true course. Your answer choice is going to be A. A couple things to note, and I already went over the first part, is when you're crossing the equator, both of these plus or minus options change to a minus sign. So in this case, if we were to start in the north and end in the south, this formula would be cosine lat 1, cosine lat 2, cosine D low, minus sine lat 1, sine lat 2. Same thing with this formula down here. Our first sine of lat 2 would be negative if we are crossing the equator. In this case, we're not, so we're good there. The second thing I want to note is that when you're using the second formula, the initial course formula, we want to plug our distance in its degrees, in our degree form, degrees with a decimal. So our distance is 53.56. You're not going to plug 3,213.5 nautical miles into that formula. You want to keep your distance in degrees. So this is how you do a great circle. It's a bit more involved than the other sailing problems, but just follow the steps, keep it simple, and do great.